Stop memorizing textbook pages that just aren't going to get you the marks. Today, in this explainer, we're reverse engineering the absolute perfect exam answer for Cambridge IGCSE Physics 0625. Look, we interact with invisible waves every single second of the day, right? From the light hitting our eyes to the Wi-Fi connecting our phones. Yet their specific testable properties, that's exactly where students lose the most points. So we're skipping all the fluff today. We're going straight into the mind of the examiner to secure those top band grades on the electromagnetic spectrum. Okay, let's dive straight into a classic Cambridge exam prompt. It asks you to explain why microwaves are used for communication with artificial satellites instead of radio waves, and it's worth 3 marks. Now, 3 marks might not sound like a huge deal, but they absolutely dictate your grade boundaries. When students see a 3-mark explain question, honestly, panic sometimes sets in. Why? Because it requires multiple linked scientific points, not just one memorized fact. And literally thousands of students lose these easy marks every single year simply because they fundamentally misunderstand what the examiner is actually asking them to compare. So let's break down a very typical but completely fatal student answer. A student might write, microwaves are used for satellites because they travel fast. Boom, that scores absolutely 0 marks. Nothing. But why? I mean, they do travel fast, don't they? To build a proper top-end answer correctly, we first really need to understand the trap the student fell into and why examiners are strictly trained to give this exact phrasing 0 credit. You see, knowing the core physics simply isn't enough if you're making a fundamental communication errors. There's basically an examiner's secret checklist of common mistakes that will completely tank your grade. Things like missing units in calculations, which immediately makes a number scientifically useless, or rounding numbers way too early in a multi-step problem that just snowballs into a totally wrong final answer that the mark scheme absolutely cannot reward. And going back to our student's answer, they travel fast, well, that's the ultimate vague explanation without evidence. It lacks specific variables, it lacks comparative data, and it totally ignores the actual scientific properties separating different types of waves. Ordinary revision fails because it just doesn't train you to avoid these exact pitfalls. All right, let's quickly reground ourselves in the core facts of the electromagnetic spectrum. Think about the structural relationship here. As we move from gamma rays up to radio waves, the wavelength increases. Radio waves have the absolute longest wavelength. But consider the frequency. It increases in the exact reverse direction. That means gamma rays have the highest frequency and radio waves have the lowest. This whole thing is strictly governed by the wave equation. Velocity equals frequency times wavelength. Since the speed of all EM waves is constant, as one variable goes up, the other simply must proportionally go down. You absolutely have to lock this inverse relationship into your memory. And this brilliantly illustrates why we need a rigorous system to answer these questions. Let me introduce you to the Examiner Whisper Framework. This is your 4-step ultimate quick win for securing top band marks. Step 1, state the concept. Step 2, provide evidence or data from your own knowledge. Step 3, apply scientific reasoning to connect those two things. And finally, Step 4, wrap it all up in exam-safe wording. If our student who wrote they travel fast had just paused to use this simple framework, there is no way they would have scored a 0. Right, so the absolutely crucial point here revolves around a very specific number, 3 times 10 to the 8th meters per second. That is the speed of light in a vacuum. And here, my friends, is the fatal flaw in that student's answer. The vast expanse between Earth and an artificial satellite is space, which is, of course, a vacuum. Every single electromagnetic wave, from radio all the way to gamma, travels at this exact same incredibly high speed in a vacuum. So saying microwaves are used because they travel fast is scientifically meaningless as a comparison. Why? Because radio waves travel at the exact same speed to the satellite. Speed is definitely not the differentiator here. In a moment, I'll show you the hidden examiner clue that completely changes how you answer hazards questions. But first, you need to lock in the framework that makes that clue super obvious. Let's return to our original problem, bridge what we've just learned, and finally solve that microwave and satellite communication question the exact way a Cambridge examiner demands. So let's see how this actually builds our perfect answer by applying our 4 steps. First, the concept. We're talking about wave properties. Next, the evidence. Microwaves have a shorter wavelength and a higher frequency than radio waves. Now for the scientific reasoning. Because of these very specific properties, microwaves can pass straight through the Earth's atmosphere and the ionosphere. The ionosphere, by the way, is this dense layer of charged particles high up above the Earth, and it acts like a massive mirror to lower frequency radio waves.
Because radio waves just get reflected back down to Earth by this layer, they never actually reach the satellite in space. Microwaves, however, have the right frequency to just punch right on through. Applying that specific reasoning wrapped up in that exam-safe wording guarantees you all 3 marks, every time. Okay, let's escalate the stakes a bit and shift our focus. Here is a much harder, multi-mark Cambridge-style scenario. Describe the harmful effects on people of prolonged exposure to the highest frequency electromagnetic radiation. 2 marks. Now, I want you to actively engage with this explainer right now. Seriously, pause and predict. Apply that 4-step framework, concept, evidence, reasoning, exam-safe wording, and mentally construct your answer before I reveal the examiner's correction. Need a quick hint? Think really carefully about how the frequency relationship we just went over might physically impact human tissue. Now, what's really interesting here is the direct biological correlation. The energy associated with an electromagnetic wave increases directly with its frequency. Therefore, it makes total sense that the highest frequencies are inherently the most dangerous to us. While infrared might cause surface burns and ultraviolet leads to sunburn and eye damage, think about the highest end of the spectrum. X-rays and gamma rays carry so much energy that they are actually ionizing. That means they literally pack enough punch to physically knock electrons straight out of the atoms inside your DNA. And that is what causes severe, deep tissue cell damage and devastating mutations.
So let's do a spot the error correction. The 0-mark answer says, they are dangerous and cause burns. See how vague that is? It applies to the wrong, lower energy part of the spectrum, and it entirely misses the scientific reasoning. But look at the top band framework answer. It applies our 4 steps flawlessly. For concept and evidence, it states, high frequencies like X-rays and gamma rays carry the most energy. Then, for scientific reasoning and exam-safe wording, it adds, causing severe cell damage. Boom, 2 out of 2 marks, secured. Using this method literally eliminates the guesswork completely.
So, we've mastered the core EM wave properties, the inverse relationship between frequency and wavelength, and the severe hazards of ionizing radiation. We have totally reverse-engineered the logic. But what happens when the exam suddenly shifts from these wave hazards to differentiating between analog and digital communication signals? This is where the mark scheme drastically changes its expectations, and our framework needs a very specific tweak to handle digital data transmission. To solve this digital signal problem, you really have to ask yourself a pretty provocative question. In a world totally full of physical background noise and constant interference, why does translating a continuous, natural wave into a simple binary code of 1s and 0s suddenly make our modern communications perfectly clear? Well, we'll uncover the exact answer to that and the common traps hidden by those specific question types in our next explainer. It is absolutely your mandatory next step to mastering the syllabus. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations, and I'll see you there.